Ayantika Roy, Anjali Kumari, Chayan Gupta, rename yourself with proper roll numbers.
Okay, sir.
Anjali and Ayantika. Anjali Kumari, Anjali, Ayantika.
Hello. Good morning, sir.
Good morning. Ayantika, rename yourself. Am I audible?
Yes, sir.
Yes, sir.
Ayantika, rename yourself. Okay. So, good morning to all. Let's start. I think we had finished that Compton effect, right, students?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So, lambda dash
Yes.
minus lambda, which is delta lambda, is equal to H by M naught C 1 minus cos phi. So that is this is the Compton shift. This is the Compton shift. This is called the Compton shift, and this is called lambda C or Compton wavelength. And we had calculated the Compton wavelength for a free electron. So lambda C for free electron is 0.0242 angstrom. Right? You remember that?
Yes, sir.
Yes, sir.
And next we did two questions. Origin of modified and unmodified lines. And the next was, why cannot we observe Compton effect with visible light? I think I answered both of them. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
So these were the general questions that you can expect from from Compton effect. Now let us do some numericals on Compton effect. So please write it down. Please write the question down, and then we'll discuss.
The whiteboard has.
Write down the question. X-rays of wavelength 10 picometer, X-rays of wavelength 10 picometer are scattered from a target. Find
are scattered.
are scattered from a target. Find the wavelength of the modified X-rays. Wavelength of the modified X-rays. Wavelength of the modified X-rays. And B, find the maximum kinetic energy of recoil electrons. Maximum kinetic energy of recoil electrons. Maximum kinetic energy of recoil electrons. करिए. What is the answer? Am I audible?
Yes, sir.
Yes, sir.
10 picometer implies
10 power minus 12.
10 to the power of minus 12 meter. So lambda is given. You have to find out the modified wavelength. So what is lambda prime? Lambda
I
prime
should be 10
minus
power-
lambda is h by m naught c 1 minus cos phi. Is the angle of scattering given?
No, sir.
Find the modified wavelength. Okay. Find the, I didn't give it. Find the modified wavelength at or let me write down for X-rays scattered at 45 degree. Okay.
Sir, that will be 10 to the power minus 11.
Which one?
Wavelength, first line.
Lambda.
Ah,
Into 10 to the power minus
yes.
12.
Yes. Because it is 10. Fine, right. So 1 picometer is 10 to the power of minus 12 meter. So 10 picometer implies the wavelength is 10 to the power of minus 11 meter. So that is equal to 0.1 angstrom. Am I right?
Yes, sir.
Yes, sir.
So the wavelength lambda is given 0.1 angstrom. Let us write it in terms of angstrom. Why? Because I already know this value in angstrom. H by m naught c का value मुझे पता है. H by m naught
0.0242
angstrom. So सब कुछ angstrom में आ रहा है. So I can just put lambda dash is equal to lambda plus 0.0242 into 1 minus 1 over root 2 cos of 45 degree, and lambda is 0.1. So it is 0.1 plus 0.0242 1 minus 1 over square root of 2, everything in angstrom. So that will be lambda prime. Okay. Is it okay?
Yes, sir.
Yes, sir.
So how much is lambda prime coming out to be? So how much is lambda prime coming out to be?
0.107 angstrom.
0.107 angstrom. Correct. Right. That's the right answer.
Yes, sir.
That's the right answer. Yani see students, 0.1 angstrom was incident on the target, or this was the unmodified line, 0.1 angstrom, और modified line का wavelength क्या निकला 0.107 angstrom. Is it okay?
Yes, sir.
Yes, sir.
Now the maximum kinetic energy of the recoil electron. Second wala part. Maximum kinetic energy of recoil of electron. क्या होगा बोलो तो? Any idea? Any idea? I think use common sense. Okay, can anybody tell me what is the incident photon energy? कितना है?
AC.
0.1, sir.
अरे 0.1 तो wavelength है. Energy बोलो.
P into C.
और frequency के language में
H nu.
H mu.
H
H
nu.
nu, or it is Hc by lambda.
Hc by lambda.
What is the scattered photon energy?
H mu prime.
H nu prime.
Is C by lambda prime.
Hc by lambda.
Hc by lambda prime.
By lambda prime.
तो ये हुआ इंसिडेंट फोटोन का एनर्जी, ये हुआ स्कैटर्ड फोटोन का एनर्जी. तो रिकॉइल एनर्जी ऑफ इलेक्ट्रॉन क्या होगा?
Hc by lambda minus
C
Hc by lambda prime.
रिकॉइल
Hc कॉमन हो जाएगा 1 by lambda minus 1 by lambda prime.
रिकॉइल एनर्जी ऑफ इलेक्ट्रॉन, लेट्स से द मैक्सिमम रिकॉइल एनर्जी, ये मैक्स टू मैक्स कैरी करेगा, एंड दैट इज इक्वल टू Hc by lambda minus Hc by lambda prime. Is it okay?
Hc common 1 by lambda minus
Yes,
1 by
sir.
lambda prime.
So it would be hc common 1 by lambda minus 1 by lambda prime. So अगर lambda prime के terms में चाहिए, that is the recoil energy. Students याद रखना. This is the expression for recoil energy. या तो फिर आप इसको ऐसे भी लिख सकते हो, h nu minus h nu prime. दोनों h nu minus h nu prime, whatever, or that can be written as h common mu minus mu. Is it okay?
Yes, sir.
So can we find out the recoil energy by putting lambda prime and lambda पता है 0.1 angstrom, lambda prime पता है 0.107 angstrom, h और c दोनों का वैल्यू पता है. So let us find out the recoil energy of the electron. Do it. Let us find the recoil energy of the electron. So the energy of
So 2.4 into 10 to the power minus 13 joule.
कितना बोला आपको?
2.47 into 10 to the power minus 13 joule.
शायद आंसर में कुछ गड़बड़ है, देखो एक बार चेक करो. So recoil energy is hc 1 by lambda minus 1 by lambda prime. Please do not forget to convert lambda and lambda prime to meters. 0.1 angstrom. इसका मतलब क्या है? 10 to the power of minus 11 meters. Am I right?
Yes, sir.
And lambda prime is 0.107 angstrom, and that is equal to 1.07 into 10 to the power of minus, let's say 11. Is it okay?
So 1.3 into 10 to the power minus 15.
Sure.
Sure.
Let's do the calculation. So h is 6.626 into 10 to the power of minus 34. C is 3 into 10 to the power of 8. 1 by lambda is 10 to the power of minus 11 minus 1 by lambda prime is 1.07 into 10 to the power of minus 11. So this becomes 6.626 into 10 to the power of minus 26 into 3. Right? And this becomes 0.007 into 10 to the power of minus 11 divided by 1.07 into 10 to the power of minus 22. Is it okay, everybody?
Yes, sir.
So 1 angstrom is equal to 10 to the power minus 10 मीटर होता है ना?
हाँ, तो 0.1 angstrom होगा 10 to the power of minus 11 मीटर.
Okay, sir.
और 0.107 angstrom होगा 1.07 into 10 to the power of minus 11 मीटर. ठीक है?
Yes, sir, got it. वहाँ पे थोड़ा प्रॉब्लम हो रहा था समय.
So this becomes 10 to the power of 10 to the power of minus 11. So what is the answer? Bolo.
1.3 into 10 to the power minus 3 picometer.
Meter energy. क्या निकाल रहे हो?
Sorry, sir. Sorry.
6.626.
1.3 into 10 to the power minus 36 joule.
ठीक से देखो, ठीक से करो.
1.3 into 10 to the power minus 15 joule.
The answer comes out 1.3 into 10 to the power of minus 15 joules. Check. ये आ रहा है मेरा कैलकुलेटर पे.
Yes, sir. Yes, sir.
Yes, sir. थोड़ा mistake हो गया
Yes,
sir.
sir.
Sorry, sir. यही है sir. 1.3 into 10 to the minus 15.
So if I want you to convert this into electron volt, ये आप इसमें रख सकते हो. You can keep it like this. But I want you to convert it into electron volts. Please convert it to electron volts. Convert करिए तो electron volts में. Convert this to electron volts. So this amount of joule is equivalent to how much electron volt? I told you the other day that 1.6 into 10 to the power of minus 19 joule is
8.13 into 10 to the power minus 35.
so 1.3 10 to the power of minus 35 joule is equal to 1.3 into 10 to the power of minus 15 by 1.6 into 10 to the power of minus 19.
Minus 16, sir. 5 into 10 to the power minus 16. 5 into 10 to the power of minus 16.
What? What unit key?
EV.
Electron volt. Electron
Minus
volt.
minus 16. अरे कैसे
Sir,
होगा?
8125 electron volt.
हाँ 8000 कितना बोलो 100?
25.
That's the answer.
Sir, 8125.
Oh,
Not
sorry.
80,000.
Oh, sorry. So this becomes yes. That's the answer. Yes. इसको ऊपर ले जाओगे तो 10 to the power of 4 बन जाएगा. That is 1.3 into 10 to the power of 4 divided by 1.6. So this becomes 13,000.
8125 EV.
13,000 divided by 1.6. Is it okay?
Yes, sir.
Yes.
Please calculation को ठीक से करो. अगर calculator को use नहीं कर पा रहे हो तो then it would be a problem. पूरा sum ठीक किया. Then at the end, when the calculation final result comes, if you do it wrong, your marks will be deducted. Please understand this. ध्यान से देखो यहाँ पे minus 19 है नीचे. Conversions should be you should be very careful with the conversions. So please be very
Sir,
careful.
exams में calculator allowed है?
हाँ, allowed है. बिल्कुल allowed है. Okay, calculators are allowed. So be very careful. ये क्या calculation कर रहे हो? Minus को plus करना, plus को minus करना, whatever it is. You should be very careful with your conversions and final calculation. क्योंकि पूरा step सही किया, बाद में end में answer गलत कर दिया, marks कट जाएंगे उसके. Right. So this is one example that is there. I have shown you this example just to make you understand what is the kind of numericals to expect, right? What is the kind of numericals to expect? Now let us do one more thing, and the question that comes is that the question is like this. SI question कई बार आ चुका है semester exams में, and the question is prove that the electron, the recoil energy, the electron cannot take away all the energy from the photon. This is the kind of question that you can expect. Question लिख लो पहले. Question लिख लो पहले. First write down the question. This is another question from Compton effect that you can expect. Clear?
Yes, sir.
मतलब क्या बोलना चाहता है क्वेश्चन कि you have to prove it mathematically. You have to prove it mathematically that if the what is the energy of the incoming photon?
H nu.
hc by lambda.
H nu or hc by lambda. Then there is an electron. You have to prove that mathematically that this photon cannot give all of its energy to the electron. यानी यहाँ पे कुछ scattering हुआ ही नहीं. Photon आया, उसने अपना पूरा energy यानी पूरा का पूरा जो h nu energy है, the photon gives its whole energy to the recoil electron. यानी कोई energy बचा नहीं scatter करने के लिए. पूरा का पूरा photon का जो energy है h nu, the whole energy is transferred to the electron. Prove that this cannot take place. So prove that the electron cannot take away all the energy from the photon. Is it okay? Let's prove it mathematically. ठीक है? Is it okay, everybody?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir. Yes, sir.
So let us work for the solution. Okay, what is, first of all, what is delta lambda? Delta lambda is h
Lambda
by
prime
m naught c 1 minus cos phi. So I can write it as 2h by m naught c sine square phi by 2. I can do it.
yes, sir.
Yes, sir.
And this is nothing but lambda prime minus lambda. Is it okay?
Yes,
Yes,
sir.
sir.
So what is lambda prime? So I can write this as c by nu prime minus c by nu. Lambda prime को लिखा c by nu prime और lambda को लिखा c by nu. Is it okay?
Yes, sir.
And that is equal to 2h by m naught c sine square phi by 2. Is it okay?
Yes, sir.
Yes, sir.
So what we do is, let us say, so we take c common, 1 by nu prime minus 1 by nu, and that is equal to 2h by m naught c sine square phi by 2. So I take c to the other side. This implies 1 by nu prime minus 1 by nu is equal to 2h by m naught c square sine square phi by 2. Is it okay?
Yes, sir.
Okay. Now let us do one thing. Let us let us multiply nu prime on both sides. Nu both sides. दोनों साइड में nu multiply कर देते हैं. Both sides, let us multiply nu. So what do I get? I get nu by nu prime minus 1 is equal to 2h nu by m naught c square sine square phi by 2. Is it okay?
Yes, sir.
Simple. So what is nu by nu prime? So what is nu by nu prime? Now let us put
Relative
one.
mu.
No, let us put one thing. Let us put h nu by m naught c square as a quantity called alpha. Let us put it. क्योंकि ये काफी बड़ा है तो छोटा कर देते हैं इसको एक्सप्रेशन को. So what do I get? I get nu by nu prime is equal to 1 plus 2 alpha sine square phi by 2. Is it okay, everybody?
Yes, sir.
Yes, sir.
So what is nu prime in terms of nu? तो एक काम कर देते हैं. What is nu prime in terms of nu? Let's see. So क्या मिला? ये मैं last expression रख देता हूँ. What is nu prime in terms of nu? So please write down, students. तुम लोग लिखो, मैं तब तक रब कर रहा हूँ. Nu prime in terms of nu. So nu prime equal to ऐसे लिखो. Write it down. So nu prime equal to, complete it. Right. So nu prime is equal to nu divided by 1 plus 2 alpha sine square phi by 2. Is it okay to everybody?
Yes, sir.
Yes, sir.
Okay. So let's do one thing. So what is the maximum kinetic energy? ये मिला. ये मिला मुझे. What is the maximum kinetic energy of recoil of electron? We know that, maximum kinetic energy of recoil electron is K. Let us say the kinetic energy of that electron is equal to h nu minus h nu prime.
It's nu prime.
Is it okay?
Yes, sir.
So I can take h common, nu minus, substitute nu prime in place of nu prime, this above expression. This expression को substitute. So nu by 1 plus 2 alpha sine square phi by 2. Is it okay?
So we have substituted the value of nu prime in this equation.
हाँ, ये इसमें nu prime पे ये वाला equation substitute कर दिया. Is it okay, everybody?
Yes, sir.
Yes, sir.
Right. So I can again take nu common. So the kinetic energy, maximum kinetic energy maximum of the recoil electron is h nu 1 minus 1 by 1 plus 2 alpha sine square phi by 2. Is it okay?
Yes, sir.
And that gives me h nu in brackets 1 plus 2 alpha sine square phi by 2 minus 1 by 1 plus 2 alpha sine square phi by 2. Is it okay, everybody?
Yes, sir.
So I think 1 gets cancelled out. What do you have? So what do you have for K max, kinetic energy, recoil, maximum kinetic energy of the electron? So you have K max, that is the maximum kinetic energy the electron can have, is h nu 2 alpha sine square phi by 2 by 1 plus 2 alpha sine square phi by 2. Am I right?
Yes, sir.
Now please note, isn't the denominator, सिर्फ brackets वाले को देखो, isn't the denominator greater than the numerator?
Yes, sir.
Yes.
Now 2 alpha sine square phi by 2 by 1 plus 2 alpha sine square phi by 2 is less than 1. It is a quantity that is less than 1. Sure shot?
Yes, sir.
Yes, sir.
And if this is less than 1, then this implies K max is less than h nu. Am I right?
Yes, sir.
Yes, sir.
Because ये जो ब्रैकेट में टर्म है, ये वाला जो ब्रैकेट में टर्म है, दिस इज ऑलवेज लेस देन 1. और अगर ये ऑलवेज लेस देन 1 है तो k max जो है that is always less than h mu. और what is h mu? h mu is the energy of the incoming photon.
Energy of the photon.
हाँ, तो k max कभी भी पूरा का पूरा h nu को इक्वल नहीं कर सकता. तो यानी इसका मतलब ये है कि the photon cannot give all of its energy to the electron. नहीं दे सकता. ये हमेशा कम रहेगा. इलेक्ट्रॉन का काइनेटिक एनर्जी हमेशा कम रहेगा. थोड़ा बहुत थोड़ा ही देगा, पूरा नहीं देगा. this can never be equal to. ये कभी भी equal to नहीं हो सकता. This will always be less. So this proves that the photon cannot give all of its energy to the electron. Let me take the attendance for this class, and then it's about to end. Move on to the next.
सर इसका मतलब
तुम्हारा वॉइस स्प्लिट कर रहा है. I cannot hear you.
सर
I cannot hear. Split कर रहा है. Split.
सर
Hello. Am I audible to everybody?
सर
Or is my voice
Yes,
breaking?
sir.
Yes, sir. Yes, sir. Audible. Yes, sir. You are audible.
Okay, so it's the problem with Anand. So, right. So it is 1 minute remaining. So this equation proves, or this is the proof that the photon cannot transfer all of its energy to the electron.
স্যার
हाँ, बोलो.
স্যার বলছি কি এটা যখন বার করছি তো নিউ প্রাইম তো নিউ থেকে বড়, তাহলে এইচ নিউ তো এখানে
New
এইচ
prime
নিউ
new থেকে
প্রাইমটা
বড় না. New prime new থেকে বড় না. New prime new থেকে ছোট. ফ্রিকোয়েন্সি কমে যাচ্ছে বলেছি না, ওয়েভলেন্থ বাড়ছে.
लैम्डा बड़ा है लैम्डा.
ও ঠিক আছে স্যার.
Lambda prime is greater than lambda. New prime is less than new. Is it okay?
হ্যাঁ স্যার.
Right. So that is why your kinetic energy maximum was h nu minus h nu. Okay. So that this is what you have. So this is how you prove it. Adishri, is she there or is she trying to? Adishri.